There we go. All right. So, like I said, we're going to expand on this chapter 13. And remember in chapter 13, we're looking at ANOVA, and ANOVA just means analysis of variance, right? And that's what we're doing. We're looking at the spread for all of these different groups for this numerical data. And today's topic is going to be called, or what it is called, is Tukeys. There's no R, it's not turkeys, just Tukeys. Multiple comparison. So when we're looking at this multiple comparison, we can call this a couple different things. Sometimes it's really called the Tukey-Kramer method. Or just Tukey method. You are going to hear me just call it Tukey method, which is pretty sad. I'm leaving off this person's name, Kramer. They deserve credit as well. But I leave it off. I just call it Tukey's method most of the time. So let's talk about this Tukey's method. This is going to tell us which means are different or which ones are the same. So this Tukey's comparison, this is a series of what we call pairwise comparisons. And this comparison has a family-wise error rate of 5%. So what we're talking about is like our alpha here. And when I say family-wise, what I mean is that this 5% is split up for all the different pairs. So what we're going to look at two means together at one time and see if there's a difference between two means. Well, if we have three means and we have multiple pairs, right? So if you have A, B, and C means, then you're going to look at A and B, A and C, B and C, right? So you could see how all of a sudden you have a lot of different pairs that you're going to compare. And that's what we're looking at. So that's what that pairwise, we look at two at a time. And this 5% is split up among all of those pairs. So this method is only used when we have what we call a significant ANOVA. And what I mean by a significant ANOVA, that means that we rejected the null. So when I reject the null, I'm going to run this Tukey's. So when I reject the null, that means that something is different. And then I'm going to run the Tukey's to see what is different, right? So it's kind of almost like a follow-up, right? So we can call it a follow-up if we want. So it determines which means are or are not what we call statistically different. So I just want to make a note because sometimes this wording, it's like a double negative and it just comes out because we're looking if something is statistically different, right? Meaning that the two means are different. Something has changed from all the others. Some things, it's not the same. But if you look at not statistically different, not statistically different, I'm going to write this here. It's like a double negative. So if it's statistically different, we're saying that it's different. If it's not different, then it means statistically the same. So I just like to mention that. Not statistically different means the same, that they are the same. It's just a double negative and it sounds, or sometimes it gets a little confusing when we're looking at that. So let's talk about this graphical display, and we're going to get into our testing process and everything here in a minute, but let's talk about this graphical display. So if you remember last class, I mentioned this and we started with it. So with this graphical display, this is just that display of my ranked means. So we're going to use the ranking from smallest to largest sample mean, which was last class. So let me just add that so we all remember. So remember when we were getting to know the data, and in the beginning of the problem, before we actually ran the test, we were actually, we got our descriptive statistics. So we got all our sample means for each group, and then we ranked them and we just wrote them from left to right, smallest to largest. And I said, we weren't doing anything really with it today. We're kind of setting it up, and we're going to do something with it. That was last class. And now we're going to do something with it this class. Here it is. This is what we're going to do. And it goes along with all this stuff, this Tukey's method. So this is the graphical display. So just gives you a visual. So what we're going to do is we're going to underline two groups that are not statistically different. So I'm just going to write it here again. So we're going to underline groups that are the same. So if we say that two means are the same, that means that they're equal, right? If they're the same, we're going to underline them, meaning that they're equal. I'm going to show you what I mean here in a few minutes. I will give you an example, of course. We're going to identify what is asked in the question, which is most likely about what is different. So the questions always ask something a little different, particular to each question. And if it is statistically the same or not as another group. So it just depends what we're studying, is basically what I'm saying, is how you're going to identify it. Sometimes this gets a little tricky. You just have to actually read the question. That's all I'm saying here. You have to read the question and answer the question. So the question might not just say, in general, are the means the same or not, right? It might not be general like that. It might say something specific, like, is this specific group different? Well, then we want to identify that. We want to identify if it's statistically the same or different from other groups, that kind of thing. Okay, we want to be able to answer that question. So I do have a couple examples of this. I just wanted to look through real quick on the type notes. So I'm going to pull those up. I am going to tell you that those examples are on page 5. I don't know if they're actually like numbered or anything. I don't think they are. But let's just take a look at those. So what I want to do is I want to show you a conclusion. So if we found something that's different, and what it looks like graphically, and what this looks like, you know, how we identify, and just do the little write-up. So I'm going to share my screen to our typed notes and take a look at page 5 here. So this is the wrong page. Oops. So I needed to go down. Here it is. Okay. Okay, so here it's just saying, take a look at the graphical display and the conclusion statement. So right here, example 1, it says that it's you don't get a lot of information because we're not actually running through any test here. We're just looking at the conclusion statement. So our response variable, remember this is our numerical variable, and I kind of don't like this one. This one bothers me. The pressure applied to a driver's head during a test crash. It just sounds so morbid. So we're looking at a value, right? A numerical value to associate with this pressure applied, right? So that's my response variable, and my factors are the car type. So we have 3 different groups: compact, midsize, and full size. So look at right here in the middle. You can see the ranked means. So this means that my sample mean for the midsize was the lowest, full size was in the middle, and then compact was the highest. So think about what you're talking about. Pressure applied to a driver's head. That's not good, right? It had the highest amount here. So that's just ranking the means. That's what we did last class. Now we're going to start adding the underlining, okay? So what this underlining means here is that when we ran our test and we ran the Tukeys, which we haven't learned how to do that quite yet, I'm just showing you the conclusion, that the mid-size and the full size were statistically the same, meaning that these two were not different enough from each other to say that they're different. But the compact is different. So down here, my conclusion, I don't even know what the question asked, but I'm just giving you ideas and examples of what the conclusions might look like. So based on the ranking and underlining, we can determine that the highest mean pressure is associated with the compact cars, which is the car type with the pressure that is statistically different than the other 2 car types. The lowest mean pressure occurs with both midsize and full size, since their mean pressures cannot be considered statistically different. So all I'm saying is that the compact is statistically different from the other 2 because it's not underlined with either the full or the mid, right? It's over here all by itself, and it has the highest amount of pressure, which is not a good thing, right? When you're talking about pressure applied to someone's head, that's not a good thing. So we're saying that's the highest for this compact car. It's statistically different from the other 2. And then I mentioned that the other 2 are statistically the same and they have the lower pressure. I know they're statistically the same because they're underlined, right? So just writing a conclusion based on this graphical display. Let's take a look at this other one. So occupational stress scores. So we're looking at different age groups. So under 40, 40 to 55, over 55. So the ranked means you can see are right here. So the mean for less than 40, the mean for greater 55, mean for 40 to 55. So look at what I'm saying is that the stress score is highest based on the samples for this age group 40 to 55, and it's lowest for the less than 40 group. Look at how nothing is underlined. That means everything is statistically different. Nothing is the same. If it's the same, it would be underlined. You could have underlines between all of these groups, and they could all be just the same. If that was the case, then we wouldn't have rejected our null, and we wouldn't be doing this if they're all the same. So just keep in mind that you might not have any underlines. So they all might be different from one another. And that's what this is saying. So in that case, we talk about the highest mean stress score, like I just already said, for the 40 to 50-year-old age group. Remember, you always include context, right? So you always want to say who and what you're talking about. And then I say it's statistically different than the other 2 scores. And then I mentioned the lowest. So we can also see that the less than 40 group has the lowest mean score. Okay. Sometimes, so you guys, I'm not going to lie, the conclusion is the hardest part of this whole process that we're working with, like the last class and this class, this follow-up conclusion, because there's not really a template for it. You actually have to write your own conclusion. You actually have to look at what you're studying and figure out what it means. So here in this last one, the number of times a task is performed per minute, and we have 4 different groups here, all right, for these different programs. So here, group 3 has the lowest time, and then group 2 has the highest, right? And then 1 and 4 in the middle. What I want to mention is that Group 2 has the highest amount of time, but look, it's underlined with 4. That means it's statistically the same as 4. So I can say that the groups with the highest amount of time are 2 and 4 because they're statistically the same as one another, which they're different than, well, group 2 is different from 1 and 3. And group 4 is just different from 3. Because take a look here, I have another underline, which means group 1 and group 4 are the same. That does not mean 1 and 2 are the same. If 1 and 2 are the same, you would have a big underline between the two of them. It's a little tricky. So you could just take a look at those examples of those write-ups because that can be like one of the tricky parts here. I definitely think it is a tricky part. I'm going to show you and look at that underlining real quick with you. So just for notation example, so if we're taking a look at the means, so we have mean 1, and then we have mean 3, mean 4, and mean 2, we might come up with the our conclusion that 1 and 3 are the same. I'm going to show you how to do that in a minute. So if 1 and 3 are the same, then I underline, I put a line underneath. You're just going to insert a line under them. Then you might get something that says 3 and 4 are the same. So I'm going to put another underline like that. I don't continue it. If 1 and 4 were the same, it would be another underline going from 1 to 4, and it would be like below this, okay? That would be an example of that. Same with like 3 and 2, it would be all the way down there. If 3 and 2 are the same, then 2 and 4 would probably be the same. But I don't want you to think that 1 and 4 are the same. So this right here, let me just write this here. So mu 1 and mu 3 are the same. That's what we're saying here. And mu 3 and mu 4 are the same. Those are the only ones that are the same. Everything else is different. So 2 is different from 4, 3, and 1. 4 is different from 1. Okay. So I just want you to get that 1 and 4 are not the same here. I know they both include 3, but that doesn't mean that they're the same. So those two from each other are statistically different. Okay, so this is what you're going to do for me. And then what you're going to do on my stat lab is a little different. So let's just take a look at this real quick. So on my stat lab, when you are ranking your means, it's going to have the means in the same order, or you might put them in that, I'm sorry, this was a 3, in the same order. But if something is statistically the same, where you underlined it here, 1 and 3 are the same, you're going to put an equals in between on my stat lab. And if 3 and 4 are the same, you're going to put an equals in between them, like that. Then you have to put something here. So it's going to ask you to fill in like these blanks in between. Well, what did we say here? How are we ranking these? Smallest, I'm just going to write it here. Smallest to largest, right? If something's larger, it's greater than. If it's greater than, I'm going to put a symbol here, greater than. Look at that. There we go. So we're going to just fill these all in with the just our inequality or equal signs. So let me just write here, smallest to largest. Okay. So you might have different inequality symbols here, but remember, it should always be a less than. It should always be opening towards the right because this is always a larger number. Okay. This is what you can expect to do on stat lab, on your homework. Okay. All right, let's take a look at some output. I want you to see what you can expect on the output and then what we're going to do with it. So I'm going to share my screen again. This is on page 4 of the type notes. I just want you to get a feel for what you can expect to see here on an output. So this is what my Tukey's pairwise comparison output looks like. So it's a little overwhelming because there's a lot going on, and I don't need to have a lot of different levels. I think this only had 5 levels, and you could see how much output I have. There's 2 different ways to read the output, and we're going to look at both ways today. So what I want you to look at is when you see this, it says difference of machine levels. So remember, it's a pairwise comparison. So this very first row right here, all I'm comparing is B minus A. So what this row gives me is just the B minus A comparison. So I'm just comparing B and A. I am not comparing any of the other groups at this time for this row, okay? This very first column tells me the difference of machine levels. This is my order of subtraction, B minus A. My difference of means, this is for my samples, okay? So this is the difference I'm getting when I subtract the sample mean of B or sample mean of A from the sample mean of B, okay? So B minus A. I get a positive difference, so it gives you an idea. Think about what we've been studying. If you have a positive difference when you subtract 2 numbers, it means the first number is larger, right? So this is telling me, just looking at this, that B is a larger sample mean. Okay, it gives you an idea of what's going on. I'm going to skip over my standard error of my difference. I'm not really doing anything with that. And look at right here, I have a CI output. I get a T value and a P value. We're going to look at this column right here for my CI, and we're going to study the column for the P value. So think back to when we're looking at differences, when we have like 2 means or even 2 proportions and we had a CI, right? The CI meant something to me if it was all positive, if it was all negative, or if it went from negative to positive and it included 0. Think about if it included that 0, what happened? That means when I subtract those 2 numbers, it could be 0. That means they could be the same, right? So if I have an entirely positive CI or an entirely negative CI, that means I'm showing a difference, okay? And that's what we're trying to show, right? Is we're trying to prove this. We're not prove it, but we're trying to figure out what one's different, right? So right here, I can see that B minus A gives me a CI that is all positive, so I am showing a difference. And the difference is that B is greater, okay? Let's take a look at it as a testing process. And I'm looking at my p-value. I'm gonna show you this process in a minute, but I just like to show you the output. I'm gonna have this p-value. When my p-value is less than 0.05, I'm showing a difference. So my CI and my p-value will give you the same results. I just want you to be able to do either one, right? If I ask you for one specifically, I want you to know. But see how the CI is telling me that there's a difference? My p-value tells me there's a difference. It's just when I look at the p-value, I don't know which one is higher, right? I would have to look back at the difference of means and see it's positive to know that B is higher. Does that make sense to everyone? We're kind of taking all this stuff that we've been learning all along and we're applying it, but now we're going to apply it all of this time, all of these, right? But it's a quick scan, right? Look at this next row. So I'm just going to scan down. So this next row goes negative to positive. That means it's the same. My p-value is also way larger than 0.05, so I know it's statistically the same. Look at this one, D minus A. They're different because my CI is all positive. My p-value is really small, right? So I'm doing both at the same time here. Look at this. There's something different here because they're both positive. Both negative, there's a difference. Include 0, no difference. Both negative, there's a difference. Both positive, there's a difference. Positive, there's difference. Both negatives. There's a lot of differences in this one. Okay, so I'd just like to show you guys and give you an idea of what this output's going to look like. Okay, so let's take a look at the testing process and the CIs, and I'll just put it all in writing, what we just kind of discussed by looking at that output. So for my test, so this is the test for my Tukeys, okay? And so we have this for my Tukey's method. So it's a real shortened test process. So my null is that the two levels, because remember it's pairwise, you're only looking at two at one time. So the two levels have the same mean, which I don't think we're surprised with that because a lot of the times my null means that they're the same. And my HA is that the means are different. So what you're going to do, you're going to take a look at your p-value and you want to see is it less than or equal to 0.05. Okay, that's your alpha. So if you answer yes, then of course you can reject the null. And if you reject the null, then it means the two means are different. Okay. If you answer no, that means you cannot reject the null. And if you can't reject your null, then it means the two means are the same. Or you can say not statistically different. Oops, sorry, need to bring that up there. Okay, so that's what we're looking at. So what I want to say to you here is that we're really looking for a p-value that is less than or equal to 0.05. That's what we're looking for, right? Because that means if this is true, then we have a difference. That's what we're showing. Okay. So let's talk about the CI. So how we're going to read the CI, like I mentioned. So the CI for Tukey's method. So I already said it verbally, but I'm going to just write it. Any CI that includes 0 indicates that the pair of means, right? Because you're always looking at two, could be not statistically different. Meaning they're the same. And that's what we're looking at. So we have different situations here, right, as we're used to. So we could have an all positive CI or we can have an all negative CI, and these both mean there is a difference, okay? Then we could have that CI that goes negative to positive, and this shows no difference. The same. Okay. All right, so we're going to be able to do both of these. I want you to be able to look at the CI. I want you to be able to look at the test. So make sure you can do both. But sometimes I'm not very particular and I just say run your Tukeys and it's up to you which one you're using, okay? They give you the same results, right? The same conclusion. So let's think about the conclusion. Our conclusion is going to consist of two pieces. So first is going to be the graphical display. So a lot of people leave this off. We're going to include the graphical display of ranked means. with the underlines, right? And the underlines indicate that they're the same. And the second piece is going to be my actually conclusion statement. The conclusion, I don't want to write conclusion statements when I say it, even, it makes me think of our usual conclusion statement in a testing process where we say, at the 5% level of significance. It's not that, right? This is my follow-up. There is no real statement set up for me to give you. You're going to write a true conclusion to answer the question and identify some things the same or different. Okay. So I'm just going to write this. Sometimes if it's just a general question, then you just kind of write about what you notice, what stands out to you. So let's take a look at an example. I don't think this will take too long because it's based on what we were looking at last class. I don't even know what number this is. I'm sorry, I didn't write it down. But this example is on page 7. I'm guessing it's probably example 1, but let's take a look. So I'm going to share this. If you want to go ahead and download the mini tab and try it out and work with me, you can, or if you just want to watch, whatever, that's fine too. So let's take a look at these type notes. I'm going to scroll down to page 7 and we'll take a look. There's my testing write-up. I'm going to look at that as we work through the example together, okay? So when we look at this example, so this example is about coffee machines, and we're looking at 5 vending machines, and we're studying the amount of coffee, so the number of ounces that's being dispensed. And what this is a quality control thing. So we want to know, are all 5 machines dispensing the same amount, and are they consistent, right? If you are the owner of the company of the machine, you want all your machines to be very consistent, and the buyer would like them consistent as well, and consistent across all 5 machines. So again, here we have our data like we did last class, where it looks so nice for us, right? The machine, and you can see there's machine A, B, C, D, and E. And then we studied 4 different times, right, where it was the cups were filled. And so now we have all this data, and it looks really nice this way. But remember, Minitab can't handle the data in this way. This way is unstacked, which is pleasing to the eye for us, and it's easier for us to look, but Minitab needs to see this stack. So if you download the coffee machine data file, you'll see I've already stacked the data, but we know how to do that by now, where you can go into data and then stack your data. Okay. So this says, let's get to know our data. This is the stuff we did last class, so we'll run through that real quick, and we're going to run the test for significant ANOVA, and I want to work through that with you. And then it says, what's the post hoc analysis? That is my Tukey's comparison. I probably should add that to the first page of another way it's worded, okay? So it's just like our follow-up, okay? So it says right here, if you have evidence of a difference in means, run the Tukey's comparison to determine which pairs are different and which pairs are not different, which ones are the same. So let's go over to Minitab and let's take a look at getting to know our data. So like I said, it's already stacked. Remember, you know it's stacked when you have 2 columns and one has all the numbers and the other one has a different machine. So look, it says A and then there's B and C, right? So you can kind of scroll down and see that it's stacked. I know sometimes that's a tricky thing for some people too. So remember what we do here first. We're going to take a look at the mean. So I'm going to look at my summary statistics. So go to stat, basic, display descriptive. This is nothing new. We've been doing this. This is something we really did a lot last class. So I'm going to go in here. Remember, my variable is what I'm studying, my numerical variable, that's amount, and I'm going to separate it out by machine. I don't want overall summary statistics. I want them for each machine separately. Then remember, you can go in here to statistics and you can ask for different things. I'm not going to do that today. I'm just going to click OK and just go with what I have. After all, the main thing we're looking at is the mean here, right? So take a look at these means. I've got 4.1, 6.8, 4.2, 6.35, and 5.3. So I have, they're basically around the same, but you could definitely see the 6.8 is the highest, the 4.1 is the lowest. And what we would do is rank those means, okay, in order. So you would say it's the mean of A, then the mean of C, then the mean of E, then the mean of D, then mean of B. So I'm ranking smallest to largest based on the numbers here. The next thing we would do is we would take a look at the box plots. So let's look at that. So graph box plots. So remember here, I have one Y, that means I have one column of data, and then with groups, forgot what the Mac users have to choose. It's one categorical variable with groups or something like that. Okay. And then click OK. Again, my variable is my numerical variable amount, and then I'm going to separate it out by machine. Remember, you can change anything. I am going to add the mean since that's what we're studying. So I'm going to add that. You can play around with the different output and see. You can change this from vertical to horizontal if you want. I try not to spend a lot of time doing these little things. I just want to get the picture. I just want to see what's going on. Look at how crazy this is, you guys. I didn't really think when you just look at the numbers, like you could see some of the numbers were really different from each other. But when you looked at just the descriptive statistics, they didn't seem that bad. But look at this. When you look at them all together, this looks like it's all over the place. I think everyone is going to go to machine B so they can get the most amount of coffee for their dollar, right? It's just so crazy to me. And then look at like machine D has the smallest spread. Machine E has a largest spread. Think about what that means. The spread. It means how much variation there's going on there. So machine D is the most consistent with how much coffee is being dispersed. That's what it means. And then machine E is the least consistent machine, meaning that it'll give you, smaller amounts and higher amounts. It's all over the place, okay? So that's the kind of stuff we're looking at. You could definitely see that machine B has the largest mean, and then it looks like machine A has the smallest. Okay. So it just gives us a nice visual of what's going on. All right, so let's go ahead and take a look at our testing process from last class. I'm going to just do the mini tab since we're here, and then we're going to look at the testing process. I told you I'm going to shorten it a little bit, and it's not a lot shorter. It's just a little bit shorter. We're just leaving a couple steps out. It's not even steps, a little pieces from some steps out. So let's just build our ANOVA. So you go to Stat, ANOVA. This is the same exact as last class because remember, we're building off of last class. So all of this stuff is what we did last class. Remember, I'm sorry, I clicked on something. I didn't mean to. So Stat, ANOVA, and then remember what we're going to look at is, sorry, my mouse is really sensitive right now. It must be my keyboard here. So my general linear model, and I need to fit that general linear model. So I'm going to click on this. Then remember the response variable is my numerical variable. It's the amount. It's the only one there. And then my factors are the machines. So I have a couple things one thing I can do here, but I don't have to do it. If I want to run a single NPP on my standardized residuals, I can ask for them right now by going to storage, standardized residuals, and then click OK. You don't have to do that. It's just, I do it in anticipation that I might need it later on, and it's just done for me. Then I'm going to click OK. So remember what clicking that little box gave me, this third column. And remember, if you are, I don't know, I figured this out on Thursday, I think it was actually my class. If you're a Mac user, you don't actually see your numbers right here for some of you. It's like stored in like column 497 or something. I had that happen to a couple students on Thursday. So if you're a Mac user, it doesn't mean it's not there. It's just not visible like right here in front of you. And it's okay. You don't actually need to see the numbers. Okay, so let's take a look at the output. So remember, we're just using the ANOVA, the analysis of variance. Look at my p-value is very small. If the p-value is very small, it's saying that one of the means is different. I'm not surprised because my box plots were all over the place. So this is now the case where I want to do the follow-up. So I'm going to go back to my write-up. And I don't want to write a ton, but I want to show you what it looks like and what I'm expecting here. So when I'm looking at the write-up here, so for my ANOVA test, under my population step, we're going to include the variable. We're going to include the factor. Okay, so for here, my variable is just the amount of coffee dispensed. You would just, I don't know, you could be specific. You don't have to be so specific here. You could say number of ounces, right? Because that's specifically what we're looking at, number of ounces of coffee dispensed. Like there's so many different ways you could write the variable. I'm just going to say amount dispensed. My factor is the machines. And remember, we have 5 levels. So I'm just going to include that here. I'm going to go down my method. I'm going to skip my goal, you guys. It feels so weird to do that. I almost don't like it. You don't have to do this shortened test version, but I want you to know you can. My null, right, is that they're all the same. So, oh, I was going to write mu. I can. Mu1, or I think it was A, B, and C, right? So mu A equals mu B equals mu C equals mu D equals mu E, right? And then my HA is that at least one is different. Okay, so that's what we're going to look at for the method. Then we're going to go down to the sample and include the mini tab. Then we're going to go to the results. And the results I don't think change. I think everything I had last class is the same for the results. So I'm going to report my F-test statistic. And I remember my degrees of freedom. I'm going to report and my p-value. I'm actually just going to write them out like this. Okay. So then I have my conclusion. And for my conclusion, we'll write something specific. So my mini tab, I can't write anything here. My F-test statistic, when I look at it, it's like 53.27, I think it was. And then I had degrees of freedom, which are 4, 15. And my p-value, we said, was very small. Then for my conclusion, I'm going to say, yes, the p-value is less than 0.05. So the machine, I'm just going to shorten it up a little bit, has an effect. Oops, has an effect on the amount of coffee dispensed. Okay, so sorry, don't even have that up there. So that's like our quick little write-up. So you guys can see this is a small write-up. This is shortened write-up. And then I need to include the follow-up, the Tukeys here from here, right? So now I need to look at my, what we call the post hoc or just Tukeys. And that's what we're going to look at now because this is the new stuff. Okay, so I'm going to go back to my mini tab so you guys can see where we're going to look here. So for my mini tab, I'm going to go right back where we were. So stat, ANOVA, general linear model. And look at the one right under the fit the general linear model. It says comparisons. That's where we're going to look. So I'm going to click here on the comparisons. So I need to give Minitab the information, but it will have most of it filled in for us because I already asked it to fit the model, and that's it. So I already told Minitab what my response variable was and what my factor is. So right here, my response variable is the amount. That is correct. That is right. And then the type of comparison right here, I want to keep it on that pairwise. My method, we're going to use Tukey's method. That's what we're studying right now, Tukey's method. And then I want to make sure that my factor is in here. So what I'm going to do is I want to check the box. It's in there, and I need to check the box just by clicking on that, saying, okay, that's how we're separating this data out by machine. Okay. So I just need to go one more place, and that's results down here, because I want to tell Minitab what kind of output I want. And what I want is I want this last piece right here, test and confidence intervals, because we're going to use that, right? We're going to use the test and we're going to use confidence intervals. We won't use it both at the same time, but we want to be able to use either one. So we'll click OK twice. So now we're going to get our output. We've already looked at this output because this was the output on page 3, I believe it was, that we looked at. So here we have our output. Yeah. So you guys, I know we're studying to see if there's a difference, right? But remember when I was taking a look at all this output, there was only a couple that there was a difference and everything else was the same. So if you have a lot that's the same, then sometimes it's easier just to say, okay, I'm going to look at, it's easier to look at what's the same because there's so much that was different, right? So if something's different, remember that I have all positive or all negative CI. And another easy way is this p-value, my test, would be larger than 0.05. Look, I'm just going to skim down here. Okay, so C and A are the same because my p-value is large. Let's keep scrolling down. Look at here. D and B are the same because my p-value is large. And those are the only two. I only have 2 that are large. P-value is meaning they're the same. So let's go ahead and take a look at our typed notes. We're going to bring this over. Take a look. So this is all the stuff we already talked about. Here's my shortened test process with everything right here. Excuse me. So, okay, here's my follow-up. I highlighted what was the same because I know we're studying what's different, but there's so many that are different. So when I did that, remember I'm underlining things that are the same when I'm looking at my means. Here's my ranked means down below, and I'm going to underline the ones that are the same. Remember the ranked means, it's not just A, B, C, D, E, right? They're ranked already. I did this before my test, smallest to largest, okay? Underline means that they are the same, and then I can go ahead and write right below it my conclusion about it. So it appears that the least amount of coffee that's being dispensed is associated with machine A and C, and those two are statistically the same and they're different from the others, right? Then it appears that the most amount is being dispensed from machines D and B, right? And those are statistically the same, but they're different from the other 3 machines. And that's how we're writing about our conclusion. Okay. You guys remember, don't forget, and you can see it right above, if we want to check our assumptions, our requirements up here, I have them right here. Remember, it's something I normally ask you after for this testing process. I don't always ask you to do it within the test. Okay. Anyone want me to go through how to get my requirements from Minitab? Anyone want me to add that? Everyone feels good about that, must be.